a long wire having a semicircular arc of radius r carrying a current I as shown in figure, magnetic field due to entire wire at point O is. You have to find magnetic field at O. So, we'll be adding magnetic field at O due to all the three parts. B due to PQ at O. Now here you can see that B due to a straight current carrying wire, B is equal to mu naught upon 4 pi I dl cross R upon RQ. So the angle between dl and R is along this direction, R is along this direction, dl also along the same direction. Angle here is between dl, length vector, and position vector of the point where we have to find magnetic field. The angle between the two is 0 degree. For this part also, you have angle between dl vector and position vector of the point where we have to find magnetic field is 180. So for this part angle is 0 and for this part angle is 180, and sine 0 and sine 180 both are 0 only. Both are okay. Therefore B PQ H sine theta is equal to 0, therefore it becomes equal to 0. Therefore BPQ is 0. BPQ where? BPQ at point O is equal to 0. Similarly, B of wire ST at point O is equal to 0. So each time you will have magnetic field due to a straight wire at the same direction, in the same direction, magnetic field will be 0. Now, magnetic field due to circular arc. Magnetic field due to semi-circular arc B of QS, BQS is equal to, let me write formula, mu naught upon 4 pi, and 2 pi I upon R happens to be magnetic field of a complete circle. Now you have semicircle, so you will be writing only pi, because angle the semicircle is making at this point is only of pi. So current is I, the distance is R. So this is your answer. Therefore, B net with, this is your magnitude only, this is your magnitude. Therefore, B net is equal to mu naught upon 4 pi I upon R, and direction you can obtain from right hand thumb rule. If you catch this current carrying wire with your right hand such that thumb is pointing in the direction of current, then curl of finger will give the direction of magnetic field, but there is one more way, and that is for circular current carrying conductor. Place the curl of your finger along the direction of current. So when you place the curl of your finger along the direction of current, your thumb is going inward. Thumb is going inward. So you can write in the plane of the figure, inside the plane of the figure. Okay. Now next question. Figure shows a current loop having two circular segments. Two circular segments, this one and this one, and joined by two radial lines. These are your two radial lines. Find the magnetic field at the center O. You have to find magnetic field at this very point. Now, this point is along this straight current carrying conductor. Therefore, B due to PS at O should be equal to 0, because angle it is making between position vector of the point and the direction of current is 180. B at O is equal to 0, as dl cross R is equal to dl R sine 180 degree. Okay, for this part current is 0, for this part magnetic field is 0. Now B due to RQ at O is equal to 0, as dl cross R. dl means length element. If you multiply length element with current, it will become current element. So dl, length element, and R, both are in the same direction. So here angle should be equal to, let me write the magnitude also, dl R. Here sine angle is equal to 0, so whole value becomes 0. So whenever you are to find magnetic field at the position of wire, in the direction of wire, then you should immediately take magnetic field 0. Now you have two more part, circular part. So for one, the field is above the surface of the paper. For part PQ, if you apply right hand thumb rule, if you keep the curl of your fingers along this direction, as current is along this direction, you have placed the curl of your finger along this direction. Okay, then thumb will be pointing in upward direction. So magnetic field due to this part of current carrying conductor PQ will be in upward direction at U, at O. Okay, and if you find magnetic field due to SR part, your curl of the finger will be along this direction. And then you will find that thumb is going down. So the two fields are along different directions. Let me write firstly the two fields, value of two fields. Now, B due to PQ at O is equal to mu naught upon 4 pi, and here you have to write angle in radian. So you will be converting this angle alpha. Okay, it is alpha radian. Okay, alpha radian angle into I upon R. This distance is A. Equation 1. Now, magnetic field B due to SR part at O is equal to, and this is your in upward direction. Okay, so this is your mu naught upon 4 pi, angle is same, alpha, current is same, I upon distance is changed, B. Now this is along, as per right hand thumb rule, it is along downward direction. So both the fields are in opposite direction, therefore B net is equal to bigger value minus lower value. So if denominator is small, then whole value is big. So you can write BPQ minus BSR, as BSR is smaller, as denominator in case of BPQ is large and it is upward. So upward minus smaller downward. So net field will be only in upward direction. So let me write mu naught upon 4 pi. I am taking common from the two, alpha I into 1 upon A minus 1 upon B, upward. Therefore, B net is equal to mu naught upon 4 pi alpha I into AB. I am taking LCM AB, and here B minus A. So this is answer. Now next question. The wire shown in figure carries a current of 10 ampere. Determine the magnetic field, magnitude of magnetic field at center. Given radius of the bent coil is 3 centimeter. Okay. Here you have given 90 degree. So you will subtract pi by 2 radian from 2 pi. That will be angle along this side in radian. So 2 pi minus pi upon 2. Pi upon 2 means 90 degree. And this becomes equal to 3 pi upon 2. Okay. So in radian you obtain angle 3 pi by 2. Angle is known. Radius is known 3 centimeter. Current is known 10 ampere. So you will convert centimeter into meter. So this will be 3 into 10 power minus 2 meter. Okay. So let me write the formula. Since B is equal to mu naught upon 4 pi. Then angle it is making, angle is 3 pi by 2 into I. I is 10 ampere divided by R, and R is 3 into 10 power minus 2. This is magnetic field, and when you place your right hand as per right hand thumb rule, then curl of your finger will be along this direction. Curl of your finger along this direction. Okay. Curl of your finger will be along this direction, and thumb is pointing inside. Thumb is pointing. Thumb is pointing inside. Okay. So two things we need to write. Firstly magnitude and then direction. So it is inside. This is equal to, here mu naught upon 4 pi, its value is 10 to power minus 7, and then cancel these 3, and you will find that it is equal to pi upon 2 into 10 power 3 inside the plane. And this is equal to pi upon 2 into 10 power minus 4 inside the plane. Now next question. Two identical coils P and Q, each of radius r, laying in perpendicular planes. P and Q are in perpendicular direction. For P, magnetic field at the center will be in upward direction, and this is your B due to P, and then B due to Q will be along this direction. B due to Q will be along this direction at the center, according to right hand thumb rule. When you place your curl of your right hand along the arrow side, you will find these directions. They having a common center. Find the magnitude and direction of magnetic field at the common center here for the two coils if they are carrying currents equal to, here it is carrying I current and Q is carrying your root 3 I current. Okay. So let me find magnetic field at the center. B due to P is equal to, as per formula, mu naught upon 4 pi, and it is circular loop, so total angle is 2 pi. Current is given I upon, and radius is same. What is radius? Radius R. Okay. And this is along y direction, in upward direction. This is the magnitude. Okay, let me write direction also. In upward direction. Now B due to Q, it is also a circular loop, so magnetic field will be magnetic constant mu naught upon 4 pi, and total angle it is making 2 pi, so I am writing 2 pi, and I is actually root 3 I upon, and radius is same, and this is along okay, let me take axis. If it is along x-axis and it is along y-axis. So you may also write in horizontal. Direction. Therefore, the two fields are making angle 90 degree. BQ and BP are making 90 degree angle between them. So, as per vector addition of two vectors, as per vector addition, now the two vectors are not along the same line. Now we will be using vector addition of two vectors. B net, okay, let me find first of all its magnitude. B net is equal to under root BP square plus BQ square plus 2BP BQ into cos of angle between the two, cos 90, and this part becomes equal to 0. And therefore it is equal to mu naught upon 4 pi 2 pi I upon R whole square. Let me cancel these parts, plus mu naught upon 4 pi 2 pi root 3 I. Here I is root 3 I upon R. So whole square. So here it is simplified, mu naught I upon R. Now for direction. For direction, let me come on diagram itself. When you make a rectangle using these two adjacent sides, you will find this line. This is your resultant of the two vectors. Resultant of the two vectors, and it is making angle alpha theta. If it is making angle theta with BQ, so perpendicular will be BP and base will be BQ, and we will be finding tan theta from this right angle triangle. Okay, so therefore for direction, tan theta is equal to perpendicular upon base is equal to BP upon BQ, and this is equal to mu naught upon 4 pi 2 pi I upon R divided by mu naught upon 4 pi 2 pi root 3 I upon R. So everything is cancelled, and you are left with 1 by root 3, and therefore theta is equal to 30 degree. Okay. Now next question. A circular coil having 100 turns of wire of radius nearly 20 cm each lies in XY plane, which is centered at origin of the coordinates. Okay. Here you have the coil present here. Find magnetic field at point 0, 0, 20 root 3. So x coordinate is 0, y coordinate of the point is 0, but you have z coordinate at a distance along z axis at a distance 20 root 3 centimeter. 20 root 3. So this distance given is 20 root 3 centimeter. And you have to find magnetic field at this point due to this circular loop. When this coil carries a current of, current is 2 upon pi ampere. Now since B is equal to, due to circular loop, B is equal to mu naught upon 4 pi 2 pi I upon R. And since you have how many number of turns? 100 turns. So just multiply the number of turns as the direction of current in each term is same. So magnetic field will be added. And since magnetic field is same, you can simply multiply by number of turns. So let me simplify it. Okay, it will be better to write the value of this one, that is 10 to power minus 7 into 2 pi, and I given is 2 upon pi. Distance R given is 20 root 3 centimeter. Let me convert into meter. And number of turns given is 100. Okay, so pi and pi is cancelled. Okay, direction of current is not given. If the direction is in anti-clockwise direction, then the field, we can have field at this very point. Okay. For direction is along positive z axis, means k cap for current in anti-clockwise direction. Direction is not mentioned. Direction of current is not given. So you need to assume that if current is along anti-clockwise direction, B is along positive k cap, but if current is along clockwise direction, then the direction of B will be along minus k cap. Therefore, B is given by it is also cancelling. So it becomes equal to 2 upon root 3 into 10 power minus 7 plus 2 and plus 1 along k cap. So this is equal to 2 upon root 3 into 10 power minus 4 k cap for current in anti-clockwise direction.